Module 7, Programming Understanding Logic Tables and Their Creation. Logic tables, often called truth tables, are tools used in mathematics, computer science, and philosophy to explore the behavior of logical statements or expressions systematically. They provide a structured way to evaluate the truth value of complex logical arguments based on the truth or falsity of their components. Logic tables begin with simple propositions, typically represented by letters like P or Q, which can be true or false. By listing all possible combinations of truth values for these propositions, we can map out the results of logical operations such as and, or, and not. Creating a logic table involves identifying each distinct proposition and determining the total possible outcomes, calculated as 2 to the power of the number of propositions. For example, if there are 2 propositions, the table will contain 4 rows representing every possible combination of true and false values for these propositions. Each row represents a unique scenario, and columns display the outcomes of the logical operators for each scenario. The table highlights how these operations affect the final truth value, showing, for instance, that an AND operation requires both propositions to be true for the output to be accurate. In contrast, an OR operation only requires one. Logic tables are essential tools for solving logical puzzles, testing algorithmic conditions, and verifying mathematical proofs, enabling clear visualization of logical processes and revealing the systematic structure underlying complex statements. Understanding programming expressions and solving logic tables. Programming expressions are the fundamental building blocks in coding. They perform calculations, evaluate conditions, or manipulate data within programs. They often involve operators, variables, and values working together to yield results. These expressions can be as simple as a mathematical operation like addition or multiplication, or as complex as conditional statements that guide a program's decision-making process. The primary role of expressions is to evaluate conditions or values to determine the next step in a program's execution flow, making them essential to programming logic and functionality. One typically follows a step-by-step approach to solve a programming expression, often called parsing or evaluating the expression. This process begins by analyzing the components of the expression, including the variables, operators, and values present. Different precedents and associativity rules apply depending on the type of programming language and the specific expression, determining the order in which operations are executed. Understanding and applying these rules is crucial for correctly solving expressions, as it ensures the accuracy of the outcome. After determining the order of operations, each part of the expression is evaluated in sequence until a final result is produced. Logic tables, commonly known as truth tables, play an integral role in solving complex programming expressions, particularly those involving conditional statements. These tables are visual tools that map out all possible values of expressions and their outcomes, helping programmers understand how different input values affect the final output. To create a logic table, programmers start by identifying each variable within an expression and listing all possible true 1 or false 0 values it may take. They then construct rows representing each combination of these truth values. For each row, they calculate the expression result based on the input values assigned, filling in the table systematically until all combinations have been evaluated. Logic tables are instrumental in debugging and validating expressions, allowing programmers to see how their code handles all possible scenarios. Functions, variables, and expressions in programming. Understanding their relationships and problem-solving steps in programming. Functions and variables play fundamental roles, each essential for structuring code and defining logic. Functions are blocks of code that perform specific tasks when called, enabling programmers to reuse code and simplify complex operations. Each function can take inputs, called arguments or parameters, passed in when the function is called. Variables, on the other hand, serve as containers that store data values. A variable is identified by a unique name, often chosen to represent its purpose or the kind of data it holds, making code more readable and accessible to debug. When functions interact with variables, they often perform calculations or transformations, forming expressions that drive a program's logic. Expressions in programming are combinations of variables, operators, and values that yield a result. An expression can be as simple as a mathematical operation, such as adding two numbers, or more complex, involving multiple variables and functions. To solve a programming expression, a programmer follows a series of steps. First, define the variables involved, then break down the expression to evaluate each component, starting with the innermost operations based on precedence. Finally, the result is computed according to the programming language's rules for evaluating expressions. Logic tables, or truth tables, visually map out all possible outcomes of logical expressions or operations. Each row in a logic table represents a different combination of input values, typically for binary variables, true, false, or 1/0. A logic table listing every possible combination allows programmers to see the resultant output for each set of inputs. Creating a logic table involves identifying each variable, defining its possible states, and systematically calculating the outcome for each condition. Logic tables are essential tools in programming for verifying the behavior of expressions, functions, and algorithms, especially when developing conditional logic and decision-making pathways. Understanding HTML5 and CSS, building structure and style on the web. CSS cascading style sheets, and HTML5, Hypertext Markup Language version 5, are essential technologies for web development, each playing a unique role in building and styling web pages. HTML5 is the latest version of HTML, which structures content on the web. It uses a system of tags, such as less than header greater than, less than av greater than, less than article greater than, and less than footer greater than, to define different parts of a web page. HTML5 introduces new elements that support multimedia, like less than audio greater than and less than video greater than, and graphics less than canvas GT, as well as semantic tags that make the structure more meaningful. This version emphasizes accessibility and search engine optimization (SEO), helping developers create more prosperous, interactive web pages with simpler code. On the other hand, CSS is responsible for visually styling these structured HTML elements. It controls layout, color, fonts, spacing, and complex animations. CSS follows a box model concept where each HTML element is treated as a box with properties like padding, borders, and margins that control spacing and alignment. CSS enables responsive design, allowing websites to adapt to different screen sizes using techniques like media queries. While HTML5 provides the structure, CSS offers the design flexibility to create visually appealing and user-friendly websites. They allow developers to separate content from presentation, making it easier to maintain and style web pages. This combination of HTML5 and CSS forms the foundation for nearly all modern web pages and applications, paving the way for accessible, responsive, and interactive web experiences. The CSS box model, enclosing HTML5 elements in CSS. Every HTML5 element is conceptualized as a box, a fundamental approach known as the CSS box model. This model provides a consistent framework for defining web pages' content structure, style, and space. Each HTML element is viewed as a rectangular box consisting of 4 parts: content, padding, border, and margin. The content area holds the element's primary information, such as text, images, or other media. Surrounding the content is the padding, which creates a cushion of space between the content and the border. The border encircles the padding, adding structure and definition to the element. Outside the border lies the margin, which separates the element from surrounding elements and helps define the page's overall layout. CSS uses this model to apply styling and layout techniques consistently, making it easier for developers to manage spacing, alignment, and positioning across various elements. For instance, by adjusting padding and margins, developers control the white space surrounding elements, enhancing readability and aesthetic appeal. The box model's layered structure also allows for complex designs and layouts by providing flexibility in how each layer interacts with others. Understanding that each element is enclosed in a box helps developers predict how changes in one layer will affect the overall design. The CSS box model is a visual and functional foundation for modern web design, making it a critical concept for effectively organizing and styling HTML elements. Understanding absolute cell references and the power of the $sign in Excel. Absolute cell references are a foundational tool in Excel, allowing users to lock specific cells in a formula regardless of where the formula is copied. This functionality is vital for creating accurate and consistent calculations across large datasets. In Excel, cell references can be either relative or absolute. Relative references, such as a 1, change dynamically when a formula is copied to a different cell, adjusting to the new location. In contrast, absolute cell references remain constant, ensuring that the formula consistently refers back to the same specific cell, regardless of where it's pasted. The $sign is the key to creating an absolute cell reference. Placing a $sign before the column letter, e.g., a 1, fixes the column, while placing it before the row number, e.g., $1 fixes the row. The $sign is placed before both to lock the column and row, creating a fully absolute reference, such as $1. This functionality is handy when working with formulas that depend on specific constants, tax rates, or other fixed values. By anchoring the cell reference with $signs, Excel users ensure the accuracy and stability of their calculations, even when formulas are applied across multiple rows and columns. Thus, the $sign in Excel is more than just a symbol, it represents a reliable way to maintain data integrity, making absolute cell references an essential tool for any Excel user. An introduction to JavaScript. JavaScript is a dynamic programming language used in web development to create interactive and responsive website experiences. Initially developed in the mid-1990s by Netscape, JavaScript allows developers to enhance static HTML pages by adding elements like animations, form validations, dynamic content updates, and more. Unlike HTML and CSS, which are used to structure and style a web page, JavaScript adds functionality, enabling users to interact with the content. One of JavaScript's key features is its ability to run directly in a web browser. This means that users do not need additional software to execute JavaScript code. It's executed client-side, reducing server load and improving user experience. However, JavaScript can also run server-side through environments like Node.js, allowing developers to use a single language across the entire web development stack. JavaScript's syntax is relatively easy to learn, especially for beginners familiar with basic programming concepts. Its popularity has led to the creation of numerous frameworks and libraries, such as React, Angular, and Vue.js, which simplify the development process for complex applications. These frameworks are crucial in modern web development, allowing for more structured, maintainable, and efficient code. Beyond web browsers, JavaScript is also utilized in mobile application development and IoT applications. Its flexibility, vast ecosystem, and widespread support make it a cornerstone of modern software development, allowing developers to build dynamic, feature-rich applications that work seamlessly across devices and platforms. Creating pop-up messages in JavaScript using the alert command in JavaScript. Displaying a message in a pop-up box using the alert command is straightforward. This command, often used for simple notifications, debugging, or alerts to capture the user's attention, is part of JavaScript's built-in methods for browser interaction. The alert command takes a single parameter as a string and presents this message in a dialog box on the screen. For instance, writing an alert, "Hello World," will trigger a pop-up box, displaying the text, "Hello World," to the user. The alert box pauses the script's execution until the user acknowledges it by clicking OK, making it helpful in notifying users of important information or errors in form validation. While the alert box is adequate for quick notifications, its limitations make it less ideal for extensive user interaction. It has a basic design and cannot be customized regarding styling or additional buttons, which can be restrictive in more sophisticated web applications. Modern web development often favors other approaches for more interactive notifications, such as custom modal dialogues created with HTML, CSS, and JavaScript, or third-party libraries like SweetAlert. However, for simplicity and immediate attention-grabbing notifications, especially in small scripts, or for quick debugging purposes, the alert command remains a practical and accessible option for JavaScript developers. Its simplicity ensures compatibility across different browsers, making it a valuable tool in the JavaScript developer's toolkit. The importance of quotation marks in JavaScript. String literals in JavaScript. String literals, also known as string constants, are sequences of characters used as text values within a program. These strings are essential in storing, manipulating, and displaying text, such as messages, prompts, or textual data. To define a string literal, JavaScript requires that the text be enclosed in quotation marks, either single or double. These quotation marks are crucial as they signal the beginning and end of the string to the JavaScript interpreter, distinguishing the string content from the rest of the code. Without these quotation marks, JavaScript would be unable to differentiate between the intended text and the program's code, leading to syntax errors or unintended behavior. For example, if a developer wants to store a greeting message like "Hello World" in a variable, they would write "let message equal to hello world." Here, the double quotation marks tell JavaScript that everything between them is a string. JavaScript also allows backticks for template literals, enabling string interpolation and multi-line strings, further expanding functionality. Each approach to enclosing strings plays a role in creating readable and error-free code. Consistently using the correct syntax with quotation marks ensures that JavaScript interprets string literals correctly. This allows the program to execute seamlessly while making the code easier for developers to read and maintain. In sum, quotes around string literals are foundational to effective and error-free JavaScript programming. Event handling in the browser. Understanding browser responses. Event handling is a core aspect of interactive web applications, enabling dynamic and responsive user experiences. In a browser, an event is any action or occurrence, such as a user clicking a button, pressing a key, or scrolling through a page. The browser detects each event, triggering specific functions called event handlers, as the developer defines. These handlers are essential for creating a seamless interaction between users and the web page's content. When an event occurs, the browser captures it and determines if any event listeners are associated with the element where the event originated. Event listeners are functions programmed to listen for specific actions on specific elements, such as mouse clicks or keyboard presses. If a listener is present, the browser executes the relevant handler function in response to the event. This process follows a model known as the event propagation model, where events travel through different levels of the document structure. Propagation has two main phases, capturing and bubbling. In the capturing phase, the event is registered from the outermost element inward, while in the bubbling phase, it goes from the innermost element outward. The browser's efficient handling of these events is crucial to optimizing performance and user experience. By managing responses quickly and ensuring that only targeted handlers are triggered, browsers can support complex interactivity without slowing down, making web applications intuitive and enjoyable. Event handling, therefore, is integral to responsive web design, creating a fluid connection between user input and application behavior. Understanding the iterative process. The iterative process is a repetitive approach to problem-solving and development, often used in design, engineering, software development, and other fields. It involves continuously refining and improving a solution, product, or concept through cycles of evaluation and adjustment. Each iteration creates, tests, and assesses a prototype or version based on feedback and findings. This allows for incremental improvements, enabling the final product to be more refined and better aligned with the desired outcomes or user requirements. One key advantage of the iterative process is its flexibility. Because the process is broken down into cycles, adjustments can be made at each stage, allowing for dynamic changes in response to new information, emerging challenges, or evolving requirements. This adaptability is particularly valuable in complex projects where not all details are known upfront, or when user needs might change over time. In software development, for example, the iterative process allows developers to create and test program components in stages, catching errors or identifying areas for improvement early on. Similarly, design iteration can involve repeated user testing, helping designers adjust usability, aesthetics, and functionality based on real user experiences. The necessity of iteration in design is inherently an iterative process because it requires continuous refinement to reach optimal solutions that satisfy user needs, technical requirements, and aesthetic goals. An iterative approach allows designers to address unforeseen challenges and adapt to changing requirements as the project progresses. By cycling through testing, evaluation, and improvement stages, designers gather valuable feedback, enabling them better to understand their work's real-world context and usability. Each iteration builds on the previous one, facilitating incremental improvements that gradually enhance the design's functionality, efficiency, and user-friendliness. Furthermore, iteration reduces the risks of launching a product or concept that needs to be adequately vetted. By revisiting and revising designs based on feedback, designers can identify potential problems early in the development cycle, preventing costly mistakes and improving the final output's quality. The iterative design also fosters creativity by allowing room for experimentation, enabling designers to explore alternative solutions and innovations that might not emerge in a linear process. Ultimately, iteration embodies a mindset of continuous improvement, ensuring that the final design is functional and optimized for users' needs and expectations. As design must constantly adapt to technological advances and user feedback, an iterative process is essential for delivering successful, resilient solutions in a dynamic world.